Hello, in this video I'm going to talk about parallel and perpendicular lines, as shown here in the syllabus. The formulas for the equation of a straight line are given on page 5 of your formula booklet. Parallel lines never meet or intersect, as they are in the same direction. Parallel lines have the same gradient. In the example shown, the equation of line L1, the blue line, is y equals 3x plus 4. The gradient of this line, denoted m1, is equal to 3, as can be seen on the diagram. The equation of line L2, the green line, is y equals 3x minus 4. The gradient of this line, denoted m2, is equal to 3, as can be seen here on the diagram. The lines are parallel and have the same gradient. In general, if line L1 has a gradient m1, and if line L2 has a gradient of m2, and if L1 and L2, the two lines, are parallel, then m1 is equal to m2. Their gradients are equal. The converse will also be true. So if the lines have equal gradients, if m1 is equal to m2, then the lines will be parallel. In this question, we have to find the equation of the line parallel to the given line and passing through the point 2, 5. If we begin by rearranging the given line into the form y equals mx plus c, so subtracting 2x from both sides, and then subtracting 6 from both sides. As the equation is now in the form y equals mx plus c, we can state the gradient, m1, as the number in front of x. So m1 is equal to negative 2. Using the fact that parallel lines have equal gradients, we can state that m2 will also equal negative 2. So now using the equation y equals mx plus c for the new line, L2, and replacing the gradient with negative 2. This line has to pass through the point 2, 5, so substituting these coordinates into the equation, and then solving the equation, gives c equals 9. So we can now state the equation of the required line, as it has a gradient of negative 2 and a y-intercept of 9. So the equation of the line parallel to the given line through the point 2, 5 is y equals minus 2x plus 9. Alternatively, having stated the gradient of the new line is negative 2, we could have used the formula y minus y1 equals m bracket x minus x1. Again, substituting in negative 2 for the gradient m and using the coordinates of the point 2, 5. Expanding the brackets, adding 5 to both sides, and simplifying gives the same answer as before. The gradients of perpendicular lines are also related. The equation of line L1, the blue line, is y equals 3x plus 4. The gradient of this line, m1, is equal to 3, as can be seen in the diagram. The equation of line L2, the green line, is y equals negative 1/3 x plus 2. the gradient of this line, m2, is equal to negative 1/3, shown here in the diagram. The two lines are at right angles, so they are perpendicular. If you multiply the gradients together, the result is equal to negative 1. Just to confirm that, in the calculator, 3 multiplied by negative fraction 1/3 is equal to negative 1. So m1 multiplied by m2 is equal to negative 1. So in general, if line L1 has a gradient m1, and if line L2 has a gradient m2, and if the two lines, L1 and L2, are perpendicular, then m1 multiplied by m2, the product of their gradients, is always equal to negative 1. The converse will also be true. If the product of the gradients of two lines is equal to negative 1, then the two lines will be perpendicular. In this diagram, consider the blue line, line L1, with a gradient of m1. Then the rise is equal to m1, and the run is equal to 1. Rotating L1 clockwise through 90 degrees will give L2. So line L2, the green line, is perpendicular to line L1, the blue line. And if you picture the red triangle rotating through 90 degrees as well, then the rise for L1 becomes the run for L2, and the run for L1 becomes the rise for L2, noting however that the green line is going downhill, so it has a negative rise. So if line L2, the green line, has a gradient called m2, then this gradient is equal to negative 1, that's the rise, over m1, that's the run. In general, if line L1 has a gradient m1, and if line L2 has a gradient m2, and if the two lines L1 and L2 are perpendicular, then m2 is equal to negative 1 over m1. We say that m2 is the negative reciprocal of m1. The converse will also be true. If m2 is equal to negative 1 over m1, then the two lines L1 and L2 will be perpendicular. So in the example shown here, the two lines have gradients that are negative reciprocals, and the product of the gradients is equal to negative 1. So the lines are perpendicular. In this example, the two lines have gradients that are negative reciprocals, and the product of the gradients is equal to negative 1. So the two lines are perpendicular. In this example, the two lines have gradients that are negative reciprocals, and the product of their gradients is equal to negative 1. So the two lines are perpendicular. And in this final example, these two lines have gradients that are negative reciprocals, and the product of their gradients is equal to negative 1, so these lines are perpendicular. In this question, we're asked to find the equation of the line perpendicular to the given line passing through the point 1, 6. We're asked to give the answer in the form ax plus by plus d equals 0, where a, b and d belong to the set of z, the set of integers. So if we begin by stating the given line and identifying its gradient, m1, and that's the number in front of x, so m1 is equal to 5. If we then use the negative reciprocal relationship for perpendicular lines, the gradient of a perpendicular line to the given line, called m2, will be negative 1/5. Using the equation y minus y1 equals m bracket x minus x1, substituting in m equals negative 1/5 and the coordinates of the point 1, 6. Expanding the brackets, multiplying both sides of the equation by 5, and then rearranging into the required form by collecting all the terms on one side, given the required result of x plus 5y minus 31 equals 0.